Dear friends, today we are going to see about network software. We can define a network software as network software encompasses a broad range of software that is used for design, implementation, and operation and monitoring of computer networks. Traditional networks, you can see the old networks, they are hardware based with software that is inserted into it. With the advent of software-defined networking, now the software is separated from the hardware, thus making it more adaptable to the ever-changing nature of the computer network. So what are the different stages in this network software are protocol hierarchies, design issues for the layers, connection-oriented and connectionless services, services primitives, and the relationship of services to protocols. First, let us see what are protocol hierarchies. A protocol is a set of rules and conventions agreed upon and followed by the communicating entities for data communication. A protocol outlines the what, how, and when of a communication. The three aspects of a protocol are syntax, semantics, and timings. What is syntax? It defines the format of data that is to be sent or received. Semantics is going to define the meaning of each section of bits that are transferred. Timings. It defines the time at which data is transferred as well as the speed at which it is transferred. Most networks are organized as a stack of layers, one on the top of another. The number of layers and their names vary from network to network. Each layer has a specified function and adheres to specified protocols. Thus, we obtain a stack of protocols. The figure here illustrates a four-layer network. We can see there is a physical medium underneath it, and layer 1, layer 2, layer 3, and layer 4. You take there are two devices, and these with these four layers it can interface and it can have the different layers. So in that diagram, we have seen it is a five-layer network. It is going to show the communication between host 1 and host 2. The data stream is passed through a number of layers from one host to another. Virtual communication is represented using the dotted lines between the peer layers. You can see the dotted lines, what they represent virtual communication. Physical communication is represented using the solid arrows between the adjacent layers. Through physical medium, actual communication occurs. The layers at same level are commonly known as peers. The peer basically has a set of communication protocols. An interface is present between each of layers that are used to explain services provided by lower level to higher layer. Uh, Interface. What is interface? Between each pair of adjacent layers is an interface. The interface defines which primitive operations and services the lower layer makes available to the upper one. Network architecture is nothing but a set of layers and protocols. Protocol stack is a list used by a certain system. One protocol that is called a protocol stack. What are the design issues for the layers? A number of design issues exist for the layer to layer approach of computer networks. Some of the main design issues are discussed as follows. The first one is reliability. Network channels and components may be unreliable, resulting in loss of bits while data transfer. So an important design issue is to make sure that the information transferred is not distorted. And the second design issue is scalability. Networks are continuously evolving. Day by day, they are improving or changing. The sizes were continually increasing that may lead to congestion. Also, when new technologies are applied to the added components, it may lead to incompatibility issues. Hence, the design should be done so that The networks are scalable and can accommodate such additions and any modifications. Addressing is another design issue. At a particular time, innumerable messages are being transferred between large numbers of computers. So, a naming or addressing system should exist so that each layer can identify the sender and receiver, which is sending the message or which is going to be authenticated. Error control is another important design issue. Unreliable channels introduce a number of errors in the data streams that are communicated. So the layers need to agree upon common error detection and error correction methods so as to protect the data packets while they are transferred. Another important issue we have is flow control. If the rate at which data is produced by the sender is higher than the rate at which data is received by the receiver, there are chances of overflowing. So a proper flow control mechanism should be implemented. And another design issue is resource allocation. Computer networks provide services in the form of network resources to the end users. The main design issue is to allocate and deallocate resources to processes. The allocation deallocation should occur so that minimal inference among the host occurs and there is optimal usage of the resource. And another important design issue is statistical multiplexing. It is not feasible to allocate a dedicated path for each message while it is being transferred from the source to the destination. So the data channel needs to be maintained in such a way that multiplexed so as to allocate a fraction of the bandwidth of time. Routing is one of the very important design issue. There may be multiple paths from the source to the destination. Routing involves choosing an optimal path among all possible paths in terms of cost as well as time. There are several routing algorithms that are used in network systems. Next, security is one of the significant design issue. A major factor of data communication is to defend it against threats like eavesdropping and surreptitious alteration of message. So there should be adequate mechanisms to prevent unauthorized access to data through authentication and cryptography. Now let us see what are connection-oriented and connectionless services. Connection-oriented and connectionless services are the two data transmission services provided by the network layer protocols and transport layer protocols. The connection-oriented services establish a connection prior to sending the packets belonging to the same message from source to the destination. On the other hand, the connectionless service considers each packet belonging to the same message as a different and independent entity and route them with a different path. Connection-oriented and connectionless services show different behavior at the network layer and the transport layer. Okay, we will discuss both this connection service and all this. What is connection oriented service? Connection oriented service is a data transfer method between two computers in a different network, which is designed after the telephone system. Like in telephone system, if we want to talk to someone, we just pick up the phone, dial the number of whom we want to talk with. After the connection is established, we talk and lastly we hang up the call. Similarly, the connection-oriented service first establishes the virtual connection between the source and the destination, then transfers all data packets belonging to the same message through same dedicated established connection and after all packets of a message transfer to connection. So here in this we can see how this connection oriented service is going to work. There is a source is sending some bits 4321. We have the routers connected in a network 5. Okay, how it is transferred you can see from R1 to R2, R2 to R4, and we can see that finally how it reaches the destination. To establish a connection, a source is sending a request packet to the destination. In response to which destination sends the acknowledgement packet to the source, confirming that the destination is ready to accept the data from the source. Meanwhile, the routers involved in the exchange of request and acknowledgement packet between source and destination define the virtual path that will be followed by all packets belonging to the same message. So we say that the resources involved in data transfer are reserved before transferring all packets in a message. As all the data packets in a message follow the same path, their order is preserved as they reach the destination. After sending all data packets, the source sends a special packet to terminate the connection, to which destination sends an acknowledgement confirming the termination, and all the router delete the path entry from routing. As connection-oriented service provide acknowledgement at each action, it provides reliability in the service. There are fewer chances of packet loss as they travel a predefined path. The connection-oriented services are preferred over a long and steady conversation. As the virtual path is predefined, there are rare or no chances of congestion. If we talk about the delay in data transmission, there is no delay in the transmission of packets as there is a dedicated path for it. But a substantial delay is introduced due to the acknowledgement process during the connection establishment and termination. The TCP protocol is a connection-oriented protocol.